What's up, tech wizards? Welcome back to Bazai, your ultimate hub for cutting-edge AI and cloud tech. Today, we're diving into the world of agentic architectures for retrieval-intensive applications, straight from Weaviate's awesome ebook. If you're building AI systems with Retrieval-Augmented Generation, RAG, pipelines, this is the guide you've been waiting for. We'll break down the fundamentals, compare single-agent versus multi-agent setups, and explore real-world examples to supercharge your applications. Stick around, hit that subscribe button, and let's get into it. Fundamentals of agentic architectures. First, let's talk about what makes an agentic architecture tick. At its core, an AI agent is powered by a large language model, LLM, with a defined role, like answering queries or retrieving data. But it's not just the LLM. Agents rely on three key components: reasoning, memory, and tools. Reasoning lets the agent plan by breaking down complex tasks into steps and reflecting on outcomes to adjust its approach. Memory comes in two flavors: short-term, which tracks recent interactions like conversation history, and long-term, which stores knowledge over time for personalization. Tools extend the agent's capabilities. Think vector databases for RAG pipelines, web search, or even API calls to external systems. Together, these components make agents autonomous powerhouses for retrieval-intensive tasks. Single-agent versus multi-agent architectures. Now let's compare single-agent and multi-agent architectures. A single-agent setup uses one LLM to handle everything: reasoning, retrieval, and response generation. It's low complexity, easy to manage, and doesn't need coordination between agents, making it ideal for straightforward tasks. But it struggles with complex, dynamic problems, especially if the agent has too many tools, leading to incorrect tool calls or the need for a larger, pricier LLM. On the flip side, multi-agent architectures involve multiple agents collaborating, each with specialized roles. Imagine a lead agent orchestrating a team: one agent for query decomposition, another for retrieval, and a third for generating answers. This setup excels at complex tasks, supports parallel processing, and can use smaller, specialized models for efficiency. However, it's more complex to manage, requires robust interaction mechanisms, and can be harder to debug. Choose single agent for simple use cases, but go multi-agent for dynamic, scalable systems. Multi-agent patterns and examples. Multi-agent systems can be structured using patterns like hierarchical, sequential, or network. In a hierarchical setup, a supervisor agent coordinates specialized query agents, for example, one retrieving proprietary data, another pulling public web info, and a third accessing personal accounts like email, ensuring data security by limiting tool access. A sequential pattern might have three agents in a row. The first retrieves data via a vector search tool, the second enriches it with a web search, and the third generates the final response. These patterns overcome the limitations of naive RAG pipelines, which lack query decomposition or validation, by enabling iterative retrieval and specialized roles. Plus, agents can transform data at scale, like summarizing customer reviews in a vector database, making unsearchable data searchable. There you have it, folks, agentic architectures demystified. From single-agent simplicity to multi-agent collaboration, you're now ready to build smarter RAG pipelines. If this deep dive got you pumped, smash that like button, subscribe to Bazai, and ring the bell for more AI insights. Drop a comment on how you're using agentic architectures, and I'll see you in the next video. Keep innovating and stay awesome. Subscribe to Bazai for more AI and cloud tech tutorials. Catch you next time.